Hello everybody. Today we'll have a video lecture will be devoted to the CAD-CAM systems. Let's speak about them. We'll speak about history, million of ceramic restorations, and materials for individualization. First of all, we need to discuss abbreviation CAD and CAM. CAD, C-I-D, it means computer-aided design. CAM means computer-aided manufacturing. Now about CEREC. CEREC, the most prominent representative of CAD-CAM systems in dentistry. What does the abbreviation of CEREC mean? This is an abbreviation for chairside, first letter, economical, second letter, restoration, aesthetic, ceramic. There is also another version that displays the meaning of the method, ceramic reconstruction. From ceramic, it's first two letters, and from reconstruction is first three letters. And all we have ceramic reconstruction. We would also say a system for computer modeling and manufacturing of all ceramic restorations. The CEREC system allows you to design and manufacture defect-oriented, biocompatible, metal-free, and natural-colored restoration teeth, crowns, bridges, veneers, and tabs directly in the doctor's office or in the laboratory with one patient visit without installing any temporary prostheses and etc. From highly quality and resistant porcelain. According to the results of the patient motivation analysis of the German Society for Computerized Dentistry, CEREC 3 ceramic restorations have three main advantages. Gentle preparation of the teeth, lack of metal in restoration, the possibility of treatment in one visit to the doctor without traditional costs and temporary prostheses. The history of CEREC originates from 1980, when the development of this technology began at the University of Zurich, and in 1985 a prototype of so-called yellow egg appeared. On this device, in the autumn of 1985, the first tab was made directly at the patient chair. In 1986, Siemens acquired a license to develop and release CEREC devices. In 1987, CEREC 1 was released, which included an optical extraoral 3D camera and computer module with controls and a milling device that were together. The milling unit had 4 degrees of freedom, and the processing was carried out using a diamond disc. It should be noted that this device didn't grind the chewing surface, so it was formed by the doctor in the oral cavity after fixing the tabs. In 1995, CEREC 2, the second CEREC, appeared, which in the milling device has an additional milling cutter, which turned the chewing and the inner surfaces. In our century, the beginning of our century, CEREC 3 was developed, and this CEREC, you can see it in our classrooms and simulation center. In 2009, Sirona launched the new CEREC AC, which used the blue cam intraoral camera intraoral camera, which had higher sensitivity and provided higher sensitivity even in the hard-to-reach areas. Then this camera was replaced in 2012 with OmniCam camera based on the method of confocal microscopy, which allows obtaining color optical impressions with high accuracy, and it's very important, without the use of contrasting powder. This allowed to significantly improve the results of this process and avoid a possible allergic reaction. Gradually, there was a separation of scanning devices into medical and laboratory, which had even greater capabilities. They also allowed those doctors who didn't have scanning equipment in their clinics to take and to reach all advantages of the development of CAD-CAM systems. On this slide, you can see one of these laboratory scanners, CEREC ENEOS. It should be noted that, as they wrote in 2014, only CEREC and the American Evolution 4D have the capabilities of ultra-precise intraoral images. It was in this year. And now the situation has changed radically. If in 2014 the rest of the systems produced only laboratory scanners, which are presented on this slide, and now only in Europe, we have more than 10 companies producing high-quality intraoral scanners. Here on this slide, you can see an interface of CEREC 3. You can meet it in our classrooms. And here you can see the interface of fourth generation of CEREC systems. Here you can see CEREC in Lab MC Excel grinding chamber, which comes with 4 grinding engines and diamond-coated milling cutters. Not only works more accurately, faster and quieter, but it's also more reliable and also easier to manage. The CEREC Lab MC Excel grinder has a different color display. That's from far away. You can find out at what stages the process is. Grinding white, scanning blue, the grinding process is completed green, or a system failure red. It can be several milling machines at the same time in one rule. And for remote control of the process, the color indication is very convenient. On the following slides, you can see the principles of preparation of cavities for tabs and crowns when you intend to make them using CEREC. In this case, it's necessary to maintain divergence of surfaces of 4 degrees. Regarding crowns, it's necessary to say that CEREC technology involves the use of milling unit for turning the frame, and the tip of the cutter has a certain diameter. Therefore, the structure of the stamp cannot have a shape thinner than this value. This applies for cutting edge and the shape of ledges. This is the same as on lateral tooth and for the front teeth. Let's speak about CEREC blocks. CEREC blocks, the fine structure feldspar-based ceramics for the manufacture of single restorations. Abrasive characteristics similar to enamel. A high transparency and pronounced chameleon effect. It's very easy for polishing. It has various color shades, and polychromatic block options. The blocks for the Cerex system are manufactured both by Vita and some other companies, for example, Ivoclar Vivadent. In 1997, Vita launched Inceram blocks, which are intended for the manufacture of the frames with subsequent cladding. Spinelli's Magnum are the most transparent. Then come with aluminum, and then Inceram zirconia. The most opaque frames are used for the posterior teeth and teeth with discolorate. All these frames have a strength of 400, 500, and 600, and they are fixed on cements. Multi-blocks, polychromatic blocks, have a smooth transition of color and fluorescence from dentine to the cutting edge. Available in 5 colors A to D and 2 colors bleach. Even without additional individualization, these blocks are optimal for the manufacture of single and partial crowns as well as veneers, but you need to position it well. Advantages of this system. There are several advantages of the system. A wide range of combinations of block sizes and colors allow them to be applied to any clinical situation in the patient's mouth. 3 different types of blocks for each clinical situation: inlay, onlay tabs, partial crowns, full crowns, and veneers. Bending strength of about 160 megapascal. In terms of parameters, the strength is close to the strength of natural tooth enamel, which provides not only a highest aesthetic of the restoration, but also an excellent function with the restoration contacts the patient's own teeth, as well as during thermal expansion and compression. Indications of this multi-blocks: if the single restorations, veneers, inlays, onlays, tabs, front and side, partial and full crowns. Zirconium anhydride, zirconium dioxide. Currently, zirconium dioxide is very popular, which is used not only as the material for full anatomical works, but also as the material for bridges and crowns. When after milling the frame, the technician applies ceramic layers on it. Properties of zirconium dioxide and high ratio of thermal expansion, excellent thermal insulation, low thermal conductivity, very high resistance to crack spreading, high impact strength, and the ability to conduct oxygen ions. Next one is encouraged zirconia. It's zirconia-based ceramic for high-strength bridges. High-tech ceramic material in 5 different shades, designed for long-term restorations and fine-grained dentures. Meets the highest demands of aesthetic, high resistance to aging and structural strength, excellent biocompatibility, high density, and fine grain. Vita Z cubes is pre-compressed and baked yttrium stabilized zirconia. It's very important that milling occurs in the soft phase, while the processing time of the frame and the consumption of diamond mills is reduced highly. After milling, the frames are placed in a sintering furnace, and the frame shrinks by about 20%. Have a bending strength of 900 megapascal applied to each block. It's very high coefficient. Next is Ivoclar, which produces IPS IMAX CAD blocks, lithium disilicate blocks for CAD-CAM technology. There are most popular blocks for making single crowns today. because they have extremely high statics. Also, this company produces impress blocks that are superior in aesthetics and durability. Therefore, the consumption of cutters on them is slightly higher. This is late-seed ceramic. Any CAD-CAM technology involves the use of a milling machine for turning the frame from the standard workpiece block. The machine uses diamond and carbide cutters. The tip of the drill has a certain diameter, the smallest in all systems, about 1 mm. This means that the tip of the stamp of prepared tooth should have a size not more than 1.2–1.5 mm in thickness. And milling machine manufacturers have not yet succeeded in reducing the size of the drill. Even drills of this size often breaks. The latest generations of milling machines have 5 rotation axes, which allows you to grind more complex shapes. However, to obtain the best results, it's necessary to create conditions to facilitate the milling process, smoothing all sharp corners when you prepare the tooth, rounded outlines of the stump, smooth transitions of one surface to another, rejection of additional retention elements in the form of grooves. Third system uses 2 diamond drills with a diameter of 1.2 and 1.6 millimeters and 2 shapes, conical and cylindrical. You can see it in our simulation center. It has following advantages: milling precision 25 micrometers, high-speed milling mode combined with optimum precision, making a crown not in 20 minutes but in 5–10 minutes, and suitable for all types of restoration. Thank you for paying attention. We're waiting for you in our simulation center. Thank you.